We're going to use a technique called the method of partial fractions to evaluate the integral of 1 divided by x plus 4 times x squared plus 6x plus 25. First, we have to make sure the degree of the numerator is strictly less than the degree of the denominator. That's clearly true. Degree of the numerator is 0 because just have a constant of 1. Degree of the denominator is 3. Next, we have to make sure or determine if this polynomial, second degree polynomial x squared plus 6x plus 25, is reducible or irreducible. A, which is the coefficient of x squared, is 1. B, the coefficient of x is 6. And the constant term c is 25. The discriminant b squared minus 4ac is what we use to see if the polynomial is irreducible. If this is negative, it is irreducible. In our case, it's 36 minus 4 times 1 times 25, which is 100, so that's minus 64, and it is negative. Therefore, the polynomial is irreducible. Now let's use partial fraction decomposition to break down 1 divided by x plus 4 times x squared plus 6x plus 25 into easier parts. We have a constant a over the linear term x plus 4 plus a linear expression of the form bx plus c over the irreducible quadratic x squared plus 6x plus 25. Multiply both sides by the denominator on the left side, therefore this right here, and we have 1 left on the left. A over x plus 4 times x plus 4 times x squared plus 6x plus 25 is a times x squared plus 6x plus 25 plus bx plus c times x plus 4. And now let's plug in x equals minus 4. The left side is 1. On the right, the bx plus c term is 0. And we have 16 minus 24 plus 25. That's 17 times a. Therefore, we solve for a. A is equal to 1 divided by 17. To solve for b and c, we could plug in other constants in, but it's probably easier to do the following. 1 is equal to a is already 1/17, so it's 1/17 x squared plus 6 over 17x plus 25 over 17 plus bx squared plus 4bx plus cx plus 4c. And let's write this as follows. 0 times x squared plus 0 times x plus 1 on the left. And on the right, 1/17 plus b, those are the coefficients of x squared, plus 6 over 17 plus 4b plus c, those are the coefficients of x, and then plus 25 over 17 plus 4c, those are the constant terms. So let's match these up. We have 0 is the coefficient of x squared on the left, and 1/17 plus b on the right. That gives us 0 equals 1 over 17 plus b, and b is equal to minus 1 divided by 17. And to solve for c, let's use this constant 1 on the left. That's 25 over 17 plus 4c on the right. 1 minus 25 over 17 is minus 8 over 17 equal to 4c. c is equal to minus 2 divided by 17. We still haven't used the x coefficient. On the left, it's 0. On the right is 6 over 17 plus 4b, that would be minus 4 over 17, plus c, which is minus 2 over 17. You can see that 0 equals 0, and that's just a way of checking that we did everything right so far. Now, let's return to our integral. Remember, the integral was 1 divided by x plus 4 times x squared plus 6x plus 25. It's now equal to a times the integral 1 over x plus 4, so it's 1 over 17 times the integral of 1 divided by x plus 4, plus bx plus c, so b is minus 1 over 17 x plus c, that's minus 2 over 17 divided by x squared plus 6x plus 25. So this is what we have left to do. Let's rewrite this as, first we know already the first integral. It's 1 over 17 times the natural log of absolute value of x plus 4. Then factor out minus 1/17, and that gives us the integral of x plus 2 divided by x squared plus 6x plus 25. So what we have to do is evaluate that and we'll be done. So let's leave the coefficient of minus 1/17 alone and look at this integral of x plus 2 divided by x squared plus 6x plus 25. Let's first try using substitution. Let u be the denominator, x squared plus 6x plus 25. So then du would be 2x plus 6 dx, and we divide by 2, we get 1/2 du equals x plus 3 dx. As you can see in the numerator right here, we have x plus 2, unfortunately, instead of x plus 3. So that's a slight problem. Let's fix this. And this is, here's our integral, x plus 2 divided by x squared plus 6x plus 25. What we're going to do is add 1 and subtract 1. So we didn't change the problem. But now these three terms give us x plus 3 minus 1 divided by x squared plus 6x plus 25. And we can write this as two integrals. First one, x plus 3 divided by x squared plus 6x plus 25. And then minus 1 divided by x squared plus 6x plus 25. So this integral can now be done with this substitution. It is going to be 1/2 times the integral of 1 over u du, which is 1/2 times the natural log of absolute value of u. It's 1/2 times the natural log of absolute value of x squared plus 6x plus 25. Notice that x squared plus 6x plus 25 is never negative, so there's no need to have the absolute value. We can write it as 1/2 ln of just x squared plus 6x plus 25. Let's update what we have so far. Our original integral was 1 divided by x plus 4 times x squared plus 6x plus 25. This is equal to, we already have the 1 portion, which is 1/17 times ln of absolute value of x plus 4. So this is 1 over 17 ln absolute value of x plus 4. And then we had minus 1/17 times the integral of x plus 2 divided by x squared plus 6x plus 25. Well, that integral is, part of it is this 1/2 ln, so this is minus 1 divided by 34 natural log of x squared plus 6x plus 25. And then we had 1/17 minus this integral, so this will be minus a minus plus 1 over 17 times the integral of 1 divided by x squared plus 6x plus 25. This is all now that we have left, is that integral. Let's go ahead and evaluate it. Once again, I'm going to leave the 1/17 alone. We're going to evaluate the integral of 1 divided by x squared plus 6x plus 25. So first we have to complete the square. We write x squared plus 6x plus 25 plus 9 minus 9. So these three terms are now a perfect square, x plus 3 squared, and then 25 minus 9 is plus 16. So this integral is the same as the integral of 1 divided by x plus 3 squared plus 16. And we're going to make the following substitution. X plus 3 equals to 4 times tangent theta. Dx is equal to 4 secant squared theta d theta. X plus 3 squared is equal to 16 times tangent squared theta. And x plus 3 squared plus 16 is equal to 16 times tangent squared theta plus 16, which is equal to 16 times tangent squared theta plus 1, or 16 times secant squared theta. So the integral is dx, which is 4 secant squared theta d theta, divided by x plus 3 squared plus 16, which is 16 secant squared theta. So these cancel, and we just have 1/4 times the integral of 1 d theta, which is 1/4 times theta. Now, what is theta? Well, theta is, from this substitution, we have x plus 3 divided by 4 equal to tan theta. Therefore, theta is inverse tangent of x plus 3 divided by 4. So this integral is 1/4 times inverse tangent of x plus 3 divided by 4. Finally, let's put everything together for the final solution of this problem. We had the integral 1 divided by x plus 4 times x squared plus 6x plus 25 was equal to, we had 1/17 natural log of absolute value of x plus 4 minus 1 divided by 34 natural log of x squared plus 6x plus 25. And then we had plus 1/17 times this integral, 1/4. 1/17 times 1/4 is 1/68 times the inverse tangent of x plus 3 divided by 4. And now we can add a constant of integration at the very end. And that's the answer. For more videos, visit www.mathprepvideos.com.